Today I'll reveal the hidden warning signs your crankshaft position sensor is failing, and share professional diagnostic techniques that could save you thousands in unnecessary engine repairs. This critical component silently monitors your engine's heartbeat, and when it starts deteriorating, the consequences can be both expensive and dangerous. The crankshaft position sensor stands as one of the most vital yet overlooked components in modern automotive engineering. Without this sophisticated electronic guardian, your engine control module would be essentially blind to the precise timing requirements of combustion. This sensor continuously tracks the rotation of your crankshaft, that massive 60-centimeter forged steel shaft responsible for converting piston movement into usable rotational power. Every millisecond, it feeds crucial timing data to your vehicle's computer, enabling perfect synchronization of fuel injection and spark timing. When this sensor begins showing signs of deterioration, your engine's performance can degrade rapidly, potentially leaving you stranded at the worst possible moment. The first critical warning manifests through severe engine hesitation during cold startup procedures, particularly noticeable during winter months. You'll experience extended cranking periods where the engine struggles to achieve initial combustion, often requiring multiple attempts before successful ignition. This startup reluctance stems from the sensor's inability to provide accurate positional data during the crucial initial rotation cycles. The engine control unit, deprived of reliable timing information, struggles to coordinate the precise fuel delivery and spark timing necessary for smooth startup. The second alarming symptom appears as dramatic power loss during highway driving, especially when attempting overtaking maneuvers. Your vehicle may suddenly feel sluggish and unresponsive, as if someone had disconnected half your cylinders without warning. This power reduction occurs because the failing sensor sends inconsistent signals, causing the engine management system to enter a protective limp mode. The computer restricts performance to prevent potential engine damage, sacrificing drivability for mechanical preservation. The third troublesome indicator emerges through abnormal engine knock and pinging sounds, particularly audible under load conditions. These metallic rattling noises indicate improper combustion timing caused by erratic sensor readings, disrupting the ignition sequence. The engine control module, receiving corrupted timing data, struggles to maintain optimal spark advance, resulting in premature or delayed ignition. This mistimed combustion creates harmful pressure waves that can cause serious internal engine damage if left uncorrected. If these advanced diagnostic insights are helping you understand your vehicle better and potentially avoiding costly mechanic visits, please subscribe to my channel and hit the notification bell to stay updated with my latest automotive expertise and troubleshooting guides. The fourth concerning symptom involves intermittent complete engine shutdown while driving, creating potentially hazardous traffic situations. These sudden stalls can occur without any prior warning, leaving you powerless in busy intersections or highway merging lanes. The sensor's complete signal failure causes the engine management system to lose all timing reference, immediately cutting fuel and ignition. Recovery from these episodes often requires extended cranking periods and may necessitate roadside assistance if the problem persists. The fifth notable problem presents as excessive black smoke emission from your exhaust system, indicating severe combustion inefficiency. This dark exhaust results from incomplete fuel burning caused by improper timing coordination between injection and ignition systems. The failing sensor disrupts the delicate balance of air-fuel mixture management, leading to rich combustion conditions and wasted fuel. This inefficient burning not only increases emissions but can also damage your expensive catalytic converter over time. The sixth warning sign appears through violent engine vibrations that shake the entire vehicle structure during idle periods. These tremors feel like your car is suffering from mechanical epilepsy, with intensity varying unpredictably throughout operation. The irregular firing patterns caused by sensor malfunction create unbalanced combustion forces that transmit through the engine mounts. These vibrations can become so severe that they affect steering control and passenger comfort significantly. The seventh symptom manifests as complete tachometer failure, leaving you without crucial engine speed information during operation. The gauge may show zero readings, maximum readings, or fluctuate wildly without any correlation to actual engine performance. This instrument malfunction occurs because the tachometer relies directly on crankshaft position sensor signals for accurate RPM calculation. Without reliable sensor data, the gauge becomes essentially useless for monitoring engine operating conditions. The eighth problematic indicator involves fuel system pressure irregularities that affect overall engine performance and efficiency. You may notice inconsistent acceleration response, with the engine sometimes surging forward unexpectedly or failing to respond to throttle inputs. The timing disruption affects fuel pump control and injection pressure regulation, creating unpredictable fuel delivery patterns. This inconsistency makes the vehicle difficult to drive smoothly and can stress other engine management components unnecessarily. The ninth and final warning sign presents as catastrophic timing chain or belt noise, indicating potential mechanical damage from sensor-related timing issues. You'll hear grinding, rattling, or slapping sounds from the timing cover area, especially during startup or acceleration phases. The sensor malfunction can cause timing system components to operate outside their designed parameters, accelerating wear patterns. This mechanical stress can lead to expensive timing system failures, requiring major engine disassembly for proper repair. To properly diagnose your crankshaft position sensor, you'll need specific testing procedures tailored to your vehicle's particular sensor technology. Begin by locating the sensor, typically mounted near the crankshaft pulley, on the engine block, or behind the timing cover assembly. Some vehicles position this sensor near the flywheel housing or integrated within the distributor assembly on older designs. The exact mounting location varies significantly between manufacturers and model years, requiring consultation with service documentation. For testing a magnetic pickup sensor, disconnect the connector and set your digital multimeter to measure AC voltage output. Have an assistant crank the engine while you monitor the voltage readings, which should show consistent fluctuation between 0.5 and 3 volts. The waveform should display smooth sinusoidal patterns without dropouts, spikes, or irregular amplitude variations throughout the test. Any deviation from these parameters indicates sensor deterioration, requiring immediate replacement for reliable operation. For Hall effect sensors, begin by verifying the power supply voltage with the ignition on but engine stopped. Measure between the power wire and ground, expecting to see 5 or 12 volts depending on your vehicle's electrical system design. Next, check the signal wire voltage while cranking, which should switch cleanly between 0 and supply voltage levels. Use an oscilloscope if available to verify clean square wave patterns without rounding, noise, or timing irregularities. Testing procedures for optical sensors require specialized equipment due to their sophisticated light-based detection mechanisms. These sensors typically produce digital square wave outputs that require oscilloscope analysis for proper evaluation. Check the LED power supply and photodiode circuits separately, ensuring proper voltage levels and clean signal transitions. Any contamination on optical surfaces or LED degradation will cause signal deterioration requiring sensor replacement. Professional diagnosis often involves analyzing sensor data through advanced scan tool monitoring during various operating conditions. Watch for correlation between crankshaft and camshaft position sensor readings, as timing relationship errors indicate potential problems. Monitor sensor performance during cold starts, warm idle, acceleration, and deceleration phases for comprehensive evaluation. Compare live data readings with manufacturer specifications to identify subtle degradation before complete failure occurs. Regarding continued operation with a failing sensor, limit driving to absolutely essential trips over very short distances only. The risk of complete breakdown increases exponentially with continued use, potentially stranding you in dangerous locations or weather conditions. Emergency driving should not exceed 30 km per hour to minimize stress on the compromised engine management system. Keep emergency contact information readily available and avoid isolated routes where assistance might be difficult to obtain. Replacement costs for crankshaft position sensors typically range from $150 to $500, including professional installation. The sensor component itself usually costs between $60 and $200, while professional labor adds another $90 to $300. Premium vehicle brands and complex engine designs can significantly increase both parts and labor costs for this repair. Mobile mechanics may offer competitive pricing for straightforward sensor replacements that don't require extensive disassembly procedures. Don't delay this critical repair, hoping the problem will resolve itself, as sensor failure can cause additional expensive engine damage. Early intervention prevents cascading failures that could affect timing chains, pistons, valves, and other expensive internal engine components. Professional diagnosis ensures accurate problem identification and prevents unnecessary replacement of functioning components during repair procedures. If this comprehensive technical information has helped you better understand your vehicle's operation and avoid unnecessary repair expenses, please subscribe to my channel for more professional automotive insights and activate notifications to never miss my latest diagnostic techniques and maintenance guidance.